I didn't get the joke.
I said 10-4, like over and out, but I didn't mean it. You know, like, I'm like 10-4, like that. All right, chapter 10, section 4 is inscribed angles and polygons. So we've talked about central angles, right, which is one kind of angle inside a circle. Central angle has its vertex at the center, and the value of the actual, or the measure of the angle is equal to the measure of the arc, right? Now we're going to learn about inscribed angles. So it's a different kind of angle. An inscribed angle is an angle whose vertex is on the circle. So notice where this vertex is. Okay, it's actually on the circle itself. The intercepted arc would be where it kind of like cuts that as it goes through. So inscribed is on the circle, where central is on the center.
So now when it asks for that type of arc, will they have to have lines, or would we draw lines?
What do you mean?
If it asks for like that specific arc.
Like the measure of it,
yeah.
It would at least go to, it might stop here, like it might stop here and here, but it will at least intersect there. Yeah. Okay, so by definition, it's an angle whose vertex is on the circle and whose side contains chords of the circle. So notice that those are chords. Whereas a central angle, it would have had a point at the center, and then the actual sides are radii of the circle, right? So these are chords where the central angle would be the radius. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. So central angle equals the arc. Inscribed angle is half the arc. So if I was looking for the measure of angle ABC, I would figure out what the measure of the arc it intercepts is and cut it in half. So if that was, I don't know, if that was 80, then my angle is 40. And vice versa. If I had the measure of the angle here, I would double it to get the measure of the arc. So angle is always half the arc. Theorem 10.8 says, if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So if two inscribed angles of the circle intercept the same arc, then the angles are congruent. So the one that it shows there is angle 1 and angle 2. So if I had angle 1 here and angle 2 here, they both intercept arc AB, right? So no matter what the measure of arc AB is, both of those angles are going to be half that, which means they'd both be the same, okay? If that was 60 degrees, angle 1 is 30, and if it's 60 degrees, angle 2 is also 30. So if they intercept the same arc, then they are congruent. Inscribed polygon and circumscribed circles. So an inscribed polygon is a polygon with all of its vertices on the circle. So in this diagram on the left, we would say that this triangle is inscribed in the circle. And on the right, this quadrilateral is inscribed in the circle, okay? Because all the vertices are on the circle itself. The circle is said to be circumscribed. So we say the circle is circumscribed about the circle. Oh my word. Let's be mature for another 5 minutes. Can we get it?
It's not my fault.
Yeah.
It's not. It's someone who's sitting 2 seats behind me.
What did you have to think you like?
The circle is circumscribed about the triangle or the quadrilateral. So if it's inside, it's inscribed. If it's around the side, it is what, Brennan? Can you say it without giggling?
I don't.
He doesn't trust himself to say
I don't either.
Circumscribed. There we go. Okay.
If it's outside?
So that's if it's outside, and then the inside one is inscribed.
It's not my fault. I'm not
Outside one?
They're getting me like
The circle is used. So if I reverse that, it would be like that. Now the circle is inscribed in the triangle, and the triangle is circumscribed about the circle. Yeah. All right, Theorem 10.9. Focus. Focus. All right, Theorem 10.9 says if a right triangle is inscribed in a circle Then the hypotenuse is the diameter of the circle. So let's start with that first. Start with just that first part, okay? If a right triangle, so in this diagram, if this is a right triangle, then the hypotenuse is the diameter. So think about why that works, right? What's true about the measure of the angle in the right triangle? 90 degrees. So if this intercepts this arc, that's an inscribed angle, yes?
Yeah.
So what would be true about that arc?
180.
180 degrees. If this is 180 degrees, then this is your diameter, okay? So that's just the short way about it. So if a right triangle is inscribed in a circle, then its hypotenuse is the diameter. That's the first part. Conversely means what? What does converse mean? Switch the if and the then, right? So now if I flip it and I say if one side of an inscribed triangle is a diameter, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. So if I had just taken the other side, let's say I did this. Because this is a diameter, I would know that that green triangle is a right triangle, and the side opposite the diameter would be the angle that's 90 degrees. So this works if and only if, because it's true both ways. Theorem 1010 says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So if I have a quadrilateral, which means 4 sides, right, inscribed in a circle, then all 4 angles are going to add up to 180. No, sorry, all 4 angles are going to add up to 360 because it's a quadrilateral, right? The opposite angles are going to be supplementary. So 1 and 3 would add up to 180, and 2 and 4 would add up to 180. All 4 is 360 because it's a quadrilateral, yeah. But again, think about why this happens. Like, you could have gotten there by knowing what you know already. If you had, let's say I just draw a segment from here to here. Okay, this is half my circle. This is the other half of my circle. So that would be intercepted into this angle would be half of half my circle. And this one would be half of the other half. And half of 2 halves of circle is going to be 180 degrees. So no matter what that measurement was, let's just say this is, I don't know, let's say this is 200. This would be 160. Then angle 2 would be 100 because it's half the 200. And angle 4 would be 80 because it's half of the 160. And add those together, it's 180. No matter what combination you make of that, it will always end up being 180. Does that make sense?
Yeah.
Okay. And then the reverse of that just says, if the opposite angles are supplementary, then I know this quadrilateral is inscribed in the circle. All right. An angle inscribed in a semicircle is a right angle. Think about why that's true. If it's a semicircle, right? What's true about the measure of the semicircle?
180.
This is 180. If this forms that semicircle, it's half that, so it's 90 degrees. The measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. So if I look at this diagram, here I've got a chord, here I've got a tangent. So this angle, angle 1, is equal to 1/2 of arc AB. Okay, let's say this is C and this is 2. Angle 2 would be 1/2. Good, arc ACB, that whole side. So if you just think about angles being on the circle, if they're on the circle, they're half the arc. If they're in the center, they're equal to the arc. But if they're on the circle, they're half the arc. Okay, now let's look at some examples. This just says find the value of x and y in circle O. So let's start here. All right, so what information is given? Okay, this is 110. So if that's 110, and this angle intercepts it, what's true about this angle in here? Half of that? Good, 55. What else do we know? Yep.
X is 40.
Good. This is 20, and that intercepts x. So x would be double that, which is 40. What else do we know?
Isn't y also 55? Is they intersect?
They'd have to intersect the same arc, right? So if this is the arc, look what intercepts that arc. What angle? This one, right? We just said that's 40, and this one. So this in here is 20. Does that make sense? They both intersect the same arc.
Can't you get y by if you could,
By what?
like, well, you can get y if you do the y rule.
So then you can also do, yeah, I can say that this whole arc here, which is 110 plus 40, that's 150, and this is half of that, which is 75 degrees.
Yeah, that's
Yep, you could do it either way. So x is 40, y is 75.
How'd you get 40?
The x is double, this is x, right? It's double this angle. Okay, let's look at B. So the only piece of information I'm given is that this is 20. What's that tell you?
that arc would be 40.
This arc is 40. What's that tell you? X is 20 because it intercepts the same arc. What's true about Y?
Oh, it doesn't intercept it has the diameter, so it would be 90 degrees.
Good. This is my diameter. This would be 180 degrees. Either way, I can determine that it's 90 degrees. So either it's a triangle with its hypotenuse as the diameter, which means that's a right angle, or it intersects a semicircle, which means it'd be half of 180 degrees, which is 90. With me so far? Yeah? Okay, what do we know about this?
Half.
What's half?
The y and then
So that means that
Y would be half that arc. Is that what you're saying? Yep. And X is going to be half this arc.
wouldn't it be 50?
Yep.
360 minus 1. No.
What's that 140 help with?
It gives you 70 and then...
This one would be 70. Yeah.
And that's a linear pair, so 70 might go like 180 minus 70 divided by 2.
We don't know that they're equal.
Oh, I thought those...
No, they're not like red congruency marks. They're just telling you that that's the X and that's the Y. What? But what else? What kind of shape you got inside that inside that circle? A triangle, right?
It's minus 180.
That's 60 plus 70 is 130. 130 minus, or 180 minus 130. This is 50. Now what?
Now you have
Oh, 100.
So
This is 100. Y is also 50 because it's half that. And then 100 plus 140, that's 240. Subtract that from 180.
So it's 1.
This is 120.
60.
Good. X is 60. Or we could have gone back to, Mateo, what you were saying about the linear pair. Once I had the 50 and the 70, you could also add those together and subtract them from 180. So all the rules that you know about linear pair, vertical angles, angles in a triangle, all that stuff still applies. All right, go to D. What do we know? X is 40 because it's half that 80. What else?
Y equals 42.
Why?
Because they have its side by side. Right? Where's its side angle side? Because you have a given side, then you have the
You have two sides right now.
Supplementary, like opposite.
No, but look, isn't it?
They're not parallel, so you can.
I can't. I thought.
They're both right triangles.
Oh.
How do you know they're right triangles?
Because of the diameter.
Okay, they intersect the diameter, so no, that's 90 degrees. Now what?
Y is opposite the congruent line, so I don't know. I guess.
This one's 50. Yeah. Where could you go with that?
How do you know they're right triangles?
Because they intersect at the diameter.
Flip it to see.
Not yet.
You can flip like to see where 50 will be.
So, you know,
Not yet.
This arc would be the other
This
side.
is going to be 100, right? Because that's double the 50. Everybody with me so far?
Yeah.
What do the little congruency marks on the triangles tell you? I know they're on triangles, but what kind of segments are those?
Those are,
Congruent.
those are also.
What's it called when a segment has its endpoints on the circle?
Chord.
It's a chord. What's true about congruent chords?
Angles.
So
Arcs.
arcs. They intersect congruent arcs, yes?
That'll also be.
So now this is 100.
So Y is also 50.
So now this is 50.
Oh, yeah.
It's been a whole 3 days since you had to use that one.
Hey, I was on the.
I did not want to
Questions on that one?
We're gonna have,
This one hurts.
we're gonna have proof of concept.
I don't think so.
No.
We haven't finalized your test yet, but I don't think so. But you are going to see them. So,
When?
when what? Like in the homework. All right. So circle O equals circle P. What's it mean to have congruent circles?
They have congruent radius.
Good. All their radii are the same. So this, and this. Those are congruent, right?
Yeah.
Arc AC equals arc AB. Those two are congruent. And it wants you to prove that those two triangles are congruent. How could we do it? Yeah.
Side angle side.
How? I know, like, yes. But,
Oh wait, the congruent arc gives you angle, right? So that's one angle. Then
Or the
and
vertical
then you got the side.
It's a right
and you
angle
got
because of the
one
diameter.
And then, yeah, what he said.
Diameter.
Yeah, right there.
So one is opposite of
well,
the arc.
pick a track because you just went two completely different ways. So let's pick a track. Let's say the given, right? So it's the given, yeah. So, Mateo, all right, one what you're saying is the chord, right? The chord, if the chords are congruent, if the arcs are congruent, then the chords are congruent, yes? So let's say AB is equal to AC because congruent arcs form
And then what does that also give you? Angle D and angle E are equal to
congruent chords. So now I've got this and this. Okay, I have to state that those diameters are equal. I have to say EA equals DA, and that's because, like, the definition of a congruent circle.
Okay, DO.
What?
Oh, yeah,
Now we need something about the angles, right? Because we don't know the other side. Yeah.
the opposite of the congruent arcs is one half if the arcs are equal to each other.
So angle CEA is equal to 1/2 arc AC. Angle BDA is equal to 1/2 AB. And we already know that AB is congruent to AC, so I could say that's inscribed angles equal 1/2 arcs. And CEA would equal 1/2 arc AB. That's substitution.
And you did that because they're congruent, right?
Yep. Because I already say that they're congruent. This would also be substitution. I probably would have given it to you if you did it in one step. And then triangles are congruent. Side, angle, side. Nope. We did the wrong angle. We can't do that, right? Which means what? Now we need the right angle, right? And then we can do a hypotenuse leg. Yes? Does that make sense? If we had had this angle, which you could eventually get there, then you can do side angle side, but we don't have that angle. So we actually need the right angle. Angle B Angle C. Because angles opposite diameter equal 90 degrees. Then, oh, we've got hypotenuse leg. A, B, D. So we actually didn't need those. You could have gone straight there. Yeah, you just needed the side and the two sides, and then because you needed the hypotenuse and you needed the right angle. That's definitely not the only way to do it, because you could have done that the top arcs equal 180 degrees. You could have subtracted out the parts you know and said that the other two were equal. Then you could have done side angle side. But hypotenuse leg just needed the right angle and then the one pair of congruent sides because of the arcs.
How did you get the B and C are 90 degrees again?
Because they're opposite the diameter, right? Anything that's opposite the diameter has to be 90 degrees.
Oh, okay.
So as of now, it's not finalized, but as of now, your test does not have a proof on it. There's so many properties and definitions in this chapter that you have to stay on top of it. So you need to make sure that you keep reviewing 10.1 to 10.3 because obviously all that stuff comes back into play. But then we're going to add to it all this stuff, and then it keeps going. Now we start talking about segments and tangents and all that stuff in the next couple sections. So you really want to be careful.
So you didn't use 4, 5, and 6?
No, not if you did hypotenuse leg. Yep.